This is for Year 10 Method Pathways. We're going to look at question 3 from exercise 4.2. So 4.2 is all about completing the square. Okay, we'll look at question K, N, and Q as examples. So for K, we've got x squared plus 7x plus 9. Now, the idea behind completing the square is you want to end up with a dots type pattern. So you've got a bracket that's squared and a number that's squared. Okay, so it will look something like this at the end, and then you have to factorize the bracket like this, or square root of a, and then bracket plus square root of a, something along those lines. Okay, so in order to do this, we apply the scaffold. So I'm going to put a scaffold here. We always have as bracket squared, we have x there, and we have a subtraction. That's a scaffold. So what you do is you halve the 7. So half of 7 is 7 over 2, positive 7 over 2, because we have a positive 7 in front of the x. We then square the result. So this will become 7 on 2 squared is 49 on 4. And we then drop whatever we have remaining, which is the plus 9, or the constant term. So we go plus 9 there. Now, what you do is you've got to deal with the fraction, because we want to combine these two together. So this is x plus 7 on 2 squared. Now, negative 49 on 9 plus 9. Okay, so we got to get the 9 over 4. Okay, so if you want to put a 9 over 4, you've got to times 4 by 9. So 4 9s are 36. So 36 minus 49. 36 minus 49 is, so that's 4 plus 9 minus 13. So it's minus 13 over 4. And now we've got a dots pattern. We've got something squared minus, okay, this isn't something squared, but we can make it something squared by applying a square root to it. So we use dots now. So we've got x plus 7 over 2 minus the square root of that, so it's root 13. The square root of 13 is 13. The square root of 4 is 2. Okay. We've got x plus 7 over 2 plus root 13 over 2. Okay, so that's basically what the dots factorization is. I guess the sticking point is how to combine these two fractions and how to use dots. So once you get that over that hump, it's actually not that hard. This is for k. We'll look at n now. We've got x squared plus 5x minus 2. We do the same process. Okay, I apply the scaffold. We've got x minus 2, or x squared minus, and then you fill in the blanks. Okay, so we've got half of 5 is positive 5 over 2. I square, so we've got half, we square it, so we square the result, 5 over 2, that's 25 over 4, and we drop the negative 2, so negative 2 goes there. Now again, we have to combine these two as a fraction. So it's on 4, so we want to convert the negative 2 on 4. So negative 2 times 4 is negative 8, so it's negative 8 over 4. So negative 25 over 4 minus 8 over 4 is negative 33 over 4. Okay, can you see I've done that in my head? I'm expecting you to do the same. Okay. Sometimes it might be useful to write it out, but however, you don't want to take too long to write this out. So that equals negative 33 over 4. Okay. So then you apply the dots pattern, because I know that's x plus 5 over 2, 5 over 2 minus the square root of that. So it's root 33 over 2, x plus 5 over 2 plus root 33 over 2, like that. Okay. We'll do q as well. Okay, so q, same process. Okay, I'm going to apply the scaffold, and I'm going to halve the coefficient of the middle term. So that's negative 3 over 2. square the result, so it's 9/4. Now, I want to highlight when you square anything, it's always going to be positive, okay? But because the scaffold has a negative there, you'll have a negative as a result here. You drop that, so that becomes -2. Again, all I'm doing is combining these two numbers together. So it's over 4. That's that's -8/4. So -8, -9 is -17/4. Oops, -17/4. So I apply dots. So I get x minus 3/2 minus root 17/2, x minus 3/2 plus root 17/2. Okay, and that's the complete factorization. Now I want to highlight in exercise 4.3, you're expected to go one step further, which we're like expected to solve this. So for example, let's just say this is a solved question. Let's say that equals 0. Okay, so that equals 0, that equals 0, and that equals 0. If you apply the null factor law, either x minus 3/2 minus root 17/2 equals 0, or x minus 3/2 plus root 17/2 equals 0. You can apply the null factor law. You can isolate the x by adding 3/2 to both sides and adding 17/2 to both sides. Similarly, you can apply the null factor law here and add 3/2 to both sides and subtract root 17/2 to both sides. If you combine these fractions, because they're both over 2, you can get x equals 3 plus or minus root 17/2 as something that's nice and compact. Okay? But the idea is the same. The idea is to factorize, so we'll factorize using dots and completing the square. Got our solution, and you can solve it by letting it equal 0. Okay, but that's basically what you do in the next exercise. So hopefully that helps.